We're going to start with this first unit is pretty review-like, all right? There's a lot of, there's some algebra review, there's some pre-calculus review. We just want to be all on the same page and speak in the same language when it comes to some of this stuff. So we're going to start off, and today's a little bit of a different day when it comes to examples. I'll explain that here in a little bit. But this first section in chapter 1 is called 4 ways to represent a function. Okay, and so we're just going to first delineate what those are, talk about them a little bit, and then be able to connect them. One of the things that we're going to do in calculus and on your FRQs as we get on through the year is to be able to connect graphs to equations, to properties, to characteristics, and then what happens when certain things change. And so we're going to connect these things together. So first off, okay, we're going to talk about what are those 4 ways, what are those 4 representations that we want to focus on. And the first one is a verbal, which is interesting because then it says description in words as if somebody was saying it to you, which it might not always be said, it might be just written, okay? So oftentimes, and one of the things that, again, I'm going to keep going back to when I had you a couple years ago. You know, we're a little gun shy about word problems and real life examples and that kind of thing. Well, hopefully by now you realize that there's going to be a lot more of that in calculus than you've seen in the past. So it's going to require you to interpret and understand and then apply. So that's one. Of course, another way is a numerically. It could be a table of values. It could just be some points that are given to you on a graph. It could be something that you have to generate, but that is another way to represent a function. Visually, okay, looking at graphs, and it might be a scatter plot, it might be a curve, it might be a step function, it could be a piecewise function, any kind of thing, right? Any type of graph. And then the last one that we need to talk about is an algebraic one. And that's when we're talking about equations or formulas, expressions, that kind of thing. I guess it wouldn't be an expression if it was a function. And so we're going to look at those 4 different ways. And again, one of the things that we're going to be doing is analyzing, interpreting any of those things and trying to connect them together. And find meaning in them instead of just doing it for algebra's sake, so to speak. Okay, there's going to be some meaning to it. Okay. Again, when we're talking about functions, we're talking about algebra stuff here. So that's kind of our review. So the first thing is, if you recall, functions. Now, I used to be really nitpicky in algebra about whether you used f of x or if you used y, and if there was no y in the problem and all that stuff. Like, that is all gone. We are at a high enough level where we can understand and appreciate that f of x and y are the same thing, or g of x or h of x or whatever. You will not lose points on an exam for putting a y when the problem has an f of x. That will not cost you points, so we're not going to do that, okay? So a function is a rule. It could be, in this particular case, the function is named f. It could be named something else. Each element x has exactly one f of x, okay? And instead of saying maybe use f of x instead of y, they're replaceable. They're interchangeable, right? Each x has only one y. Just as a refresher about what a function is. And then, of course, you guys know this. The domain, the set of all x values. Just trying to reintroduce some terminology, make sure we're on the same page, right? So you should be able to figure out what the next line is going to be. What's it going to be? Range, yeah. Range set of all f of x as x varies throughout the domain. So here's the thing that's a little bit different. Why didn't it just say set of all y's? Because one of the things that we give particular attention to in calculus is this idea of what is happening to y as x is changing. rate of change. I mentioned to you guys the other day about slope and how slope is an elementary idea when it comes to algebra, but it's a prevalent idea when it comes to calculus from the perspective of what is happening to the y as x is changing. And it will not always change. It will rarely change in calculus in a linear fashion like we were used to a couple of years ago. So this is a really important idea to be thinking about. As x is changing, you've worked with limits a little bit, right? So as x approaches a particular value, what is happening to y? What is happening to y if you approach it from the left, if you approach it from the right, that kind of idea, okay? So that's where we take that simplistic idea that we've been using in earlier classes and we can investigate it a little further. And then, of course, another way to identify something is, as a function, is to consider the vertical line test. And that's why it's a question mark. It's not vertical line test. That's not what it is. It's like, think about, use that idea to question whether or not something is a function. And if you recall, if I can draw a vertical line that ever hits the graph more than once, then it's not a function. If it only ever hits the graph one time, then it is a function, okay? And so now, again, we're at that place where saying it passes the vertical line test is fine, because this is not an algebra class, this is a calculus class. Any questions about that brief summary of functions? I get that you maybe haven't worked with that idea exclusively for a little bit, but hopefully it's been included in what you did last year, and obviously I know we did some of it a couple years ago. So let's create, let's look at some characteristics. Okay? One of the things we'll spend a lot of time talking about in calculus is if the function is increasing or decreasing, if it's constant, because when we apply it to real world situations, we want to know what's happening to the y as the x is increasing or decreasing, etc. So we're going to come up with some characteristics. We're going to identify some characteristics for each of these and things that you want to look for, and things, to be truthful, that should become second nature to you, okay? And they could be, you could see them visually, that you could see them algebraically. You could see it in a table. There could be some patterns there, but those are the things you're going to want to pay attention to. So let's start with the increasing function. Okay, what do I know about the slope of an increasing function? It is positive, very good, okay? So the slope of an increasing function will have positive slope. Because if we think about it, we're always talking about from left to right as x is increasing, going from smaller to bigger. As x is increasing, then y is increasing, which means the slope is positive, okay? And so those are look-fors, all right? Another way, again, to think about it is that each subsequent y value is bigger than the one before it when each subsequent x value is bigger than the one before it, okay? So what this is saying in mathematical terms is y is always getting bigger as x is getting bigger. It's a simple way to say it, but here's a mathematical way to express it. The preceding y is smaller than the subsequent y when the preceding x is smaller than the subsequent x. Does that make sense? Okay. So then with decreasing, what kind of slope is it going to have? It's going to have negative, and all of this is just going to be flipped, right? So it's going to have negative slope, and then the y's are actually going to be getting smaller even as the x gets bigger. Okay, so that part stays the same, but the y's get smaller as the x gets bigger. And this is foundational idea of calculus, because like I said, we'll talk about rate of change, we'll talk about average rate of change, we'll talk about instantaneous rate of change, which is all just fancy words for different kinds of slope at a particular point or in a particular range of points. And then a constant function, of course, now we're saying the slope doesn't change at all. It stays the same. It's a horizontal line. And so the y values won't ever change. They will actually, so how this looks is basically the same kind of format, except now the y values just stay the same as the x values increase, or decrease for that matter. This is all just basic algebra stuff. Maybe you talked about it a little bit in pre-calc last year. We talked about this in general in algebra, but we never went into the detail that we will, and we're talking about today, or the depth for that matter. All right, the next thing that we need to talk about are two specific types of functions that we might have. Okay, we can have an even function or we can have an odd function. Now, throughout the course of your homework, you're going to be asked to identify them and determine if a function is even or odd based on particular characteristics. And you're going to have to prove it. It's not going to be as simple as looking at the graph, okay? All right, even function. That means it is symmetric about, symmetric about the y-axis. That means it has bilateral symmetry. So the right-hand side of the y-axis and the left-hand side of the y-axis, the graphs will be mirror images of each other. Now, algebraically, there's a way to determine if that is the case. Okay, here's what you have to look for. Okay, if f of x always equals f of the opposite of x. I don't want to say negative x because x could be negative to begin with. So f of x equals f of the opposite of x. We see that with parabolas, right? If you have a parabola in standard position, the right-hand side is the mirror of the left-hand side. Okay? And so one of the things that you would have to be able to do is, here's this in practicality, okay? If AB is a point on the graph, then negative, or the opposite of AB, is also a point on the graph. So notice the y values actually stay exactly the same. The x values have different signs. That's the definition, really. All that in a nutshell is the definition of what makes an even function. And a lot of the time, the degree will be an even number of that function. There are things that can be done to a function that the degree could still be even and it not be an even function, so be careful, but that's kind of where the name comes from. Okay? Odd function is a totally different thing. I mean, your gut probably would say, oh, symmetric with the x-axis. No, it's not. Do you know what an odd function is? Symmetric to origin. Oh, you could. You learned that. Was that last year? Amazing. No, I see this is great. Perfect. Symmetric about the origin. Which is, in algebra, we didn't talk about symmetry with the line y equals x. We didn't talk about symmetry with the origin. In pre-calc, I think you did. Okay? And how that looks algebraically is a little bit different than what you see on the left there. Okay? So not only does the sign of the x change, but the sign of the y changes. Okay? So when the sign of the x changes, the sign of the y changes. Right? Inside, outside. And so, like I have it written on the left, I have another way of writing that as well. If the point AB is on the graph, then you change both the signs and it'll be on the graph too. The opposite of. Right. Remember, I know we want to think of this as negative A, or negative B. A better way to think about it is the opposite of A and the opposite of B. So if A by itself was already negative, then the opposite of the negative would turn it positive. So yeah, you're switching. Both signs switch. I know when we see this, we interpret it as A and B both being positive. That's just our nature to look at this and go, well, they both must be positive. But as you know, a variable doesn't always have to be positive, even though it doesn't have a negative sign in front of it, okay? Now, the next thing that I'm going to have you do, so rather than, in this case, taking a bunch of pictures and writing down crazy examples and stuff. I want you to go to Canvas and go to the 1.1 homework. I'm sure it's on your to-do list. It's probably due. I mean, it's due tomorrow, so it's probably on your to-do list for tomorrow. And you'll see there that there's a file. It says example problems or something like that. And what I would do if I were you is I would just add that, because I think you can. I think you can send it to Notability and add it to the notes that you already started, so it'll be included in the same note. And then we'll just work through those examples a little bit together. We're not going to do all of them, just because we don't have the time to do that. But we'll see how far we can get. Okay? Yeah, go ahead and do this one. You can do this one. We don't need to wait. Actually, I know what we're going to do today. I got an idea. What is this telling us to do? Like, if you were going to explain this to somebody else about how to do this, what would you say? Somebody, volunteer me. Volunteer you. All right, Noah, tell me.
Put h squared in the x place.
Okay, so we're gonna just put the h squared in place of the x's. What about the 2? What are we gonna do with that?
Put it on the outside.
Yeah, we're just gonna leave it alone. Let's leave it be. Okay. So I'm gonna write it down here for start. No, I'm not. So we're gonna leave the 2 alone. It's gonna just stay aside, right? And we'll leave the brackets. And so what I'm gonna do is take this h squared and we'll put it in for x. Okay. All right, somebody else. What's my next step? Exponents. Well, yeah, order of operations, right? So what does that give me? H to the 4th minus 4h squared, and then distribute, done and done. Okay? Questions on that? Issues with that?
Would we have to simplify it, or does it not matter?
Simplify which part are you asking about?
Could you take 2h squared out of it?
Oh, factor it out? No, you do not have to do that. No. This is totally fine. Now, if this was in the context of some type of equation, we're trying to find zeros and something called critical points, which you guys didn't learn anything about critical points last year, did you? Critical values, yeah. We'll get to that. When we get to those kinds of things, we might have to, but for this particular problem, nothing to do there, okay?
Dividing everything by 2.
The only thing you could do is factor a 2 out, but you can't divide. There's not another side to divide the 2 with, since it's just an expression. The truth is, this is the best answer. Okay? All right, let's go to the next one. Domain of each of the following functions. I know, there's one. I only gave you one. Now, let's talk about things that we have to guard against when we talk about the domain. Okay? When we're being asked about the domain of something, in reality, what we're trying to say is, because the domain is just the set of all x values, well, we want to know for g of x what x values are allowed. And sometimes it's easier to say what x values are not allowed. X can be every number but these. A lot of the times, that's how you want to approach domain, okay? Now, that being said, what kinds of numbers, what kind of, especially with a fraction, what can't ever happen with a fraction? You can't divide by 0. When you divide by 0, that is called undefined, right? It has no meaning. You can't divide by 0. So what we're going to do here is we're going to figure out what values will create a problem. Now, there's another piece of this that we have to look out for. So there's one is that you can't have a, so let me write that down. Okay, denominator, cannot equal 0. That's one thing to look out for. What else can't we have? What else is happening in this problem that might create an issue for us? No negatives and no radical. Okay, let's see. How can I make a little fancy thing? let's go like this. Negative, and we'll put a big old, that's fancy, right? Now, that's a square root, or a fourth root, or a sixth root, an even root. We can have negatives under there if they're odd, right? So those are the things we have to watch out for here. So one of the things that I want you to be kind of paying attention to as you're working through your homework, or just as you're going through equations in general, is looking for what are called restricted or excluded values. And that's what we're looking at here. We're gonna determine what the domain is based on what we eliminate, okay? So we have two things to figure out here. One, how can we make sure that the denominator never equals 0? And two, how can we make sure that that radical is never having a negative underneath it? Now, I'm gonna stop there. I'm gonna let you finish it. I saw some good things, I saw some interesting things, and some other things I want to talk about, all right? So the denominator equal to 0 part. Pretty straightforward, right? What can't x equal as far as this goes? X cannot equal plus or minus 3. That's where my 0 comes in. So it can never equal 3, it can never equal negative 3. Okay, now that's not going to be really part of my answer. Right, what we really want to be thinking about is there's two ways to look at this. Okay, I have x squared minus 9 also has to be greater than 0. Now you can factor that and then think about the 3 and negative 3 that way too if you want. But you can also kind of intuitively think about it. What values for x are going to allow this thing to be positive?
4.
Okay, 4. Other values. Yeah, you mean you can start thinking about actual values, right? So if I plug 3 into this, I get 0, that's a problem. All I need to do is a hair more than 3, and I'm bigger than 9. Okay, so in reality, what you're thinking is, it's got to be, x has to be greater than 3. That's one option. Well, in interval notation, we write that as close parenthesis, or sorry, it's just parenthesis. I'm confusing myself. Okay, and then from 3 to infinity. Interval from 3 to infinity. Okay, so that's part of it. Now, the other thing that can be here that's going to allow this to be greater than 0 is if I square negative 3 and smaller than that, right? Because negative 3.1, which is smaller than negative 3 squared, is bigger than 9. And so the other thing to be thinking about here is this, that it could be less than negative 3. So in this case, that's from negative infinity to negative 3. And so both of those are part of the domain. The area where I run into problems is if I'm between negative 3 and 3. Any of those numbers, when I square them, will be still less than 9. And so we exclude them. So in the end, what we write for the domain is really, and because I'm running out of room, I'm going to put these together. We would write the union of those two. I have a little bit of, no, I really don't have a lot. I'm going to write it up here. Let's just write it up here. So you'll know what it should really look like on one line. Nope, not that way. Nope. There we go. Nope, I don't like that. This is really what your domain should look like. Now, I went through a lot of gyrations to get there, trying to sort of over-explain it in case you need that, right? If you were able to get there without all of that, that is great too. I just want to make sure nobody gets lost along the way with that question. Union is this or that. It is not and. It's not the intersection. It's either this or that.
Oh, it's anything above.
So it's
okay.
3, it's bigger than 3 or less than negative 3.
Okay.
That's a mathy way of saying, so maybe you would have liked to say this instead. But, because this makes intuitively more sense, but it's not calculus, right? In calculus, things will be written in interval notation. Okay? So that's the really big difference. This is algebra 2 stuff right here. This is calculus level. This is actually pre-calculus level, but that's the way it'll be expressed in calculus. Next. We're not gonna do all of these. Okay. Think about what your gut tells you. What does your gut tell you about A? Even, odd, or neither? Okay. How about B? What's your gut telling you? Odd. How about C? Even. Right? X squared-ish. D. Odd. Okay, so we're not going to actually do these, okay? Because you're going to have ones like this in your homework. What you would have to do is plug in negative x if you think it's even. So if we think A is even, what we're going to do is plug in negative x. Simplify it and see if we get that. Let's do A. All right, let's do A. Let's do it. Okay, we think it's even. So all we've got to do is go, all right, instead of x, we're going to plug in negative x. And we wonder, are these the same? Are they?
Yes.
Sure they are. Okay, definitely even. That's the proof. Okay. Now, we said B. Let's just keep going. No, let's do D. I got more room down here. We said probably odd, right? So then what I would do is I go, okay, negative y. I'm going to take the f of x out just because it's easier to deal with, right? And then I'm going to also, I have to change, the x to negative. And we need to say, are these two things equal to each other? Right? Because if they're equal to each other, then we're good. If they aren't, then it's a neither. Or I guess it could still be an even. We could test even. I'm not feeling real confident about that. But are those the same? I mean, in theory, what I would have to do is go, are they the same? Are these two the same? Now, I did a little snazzy algebra on you, and this is how calculus is going to go. I'm going to skip a bunch of steps. I just changed. What did I do wrong? What did I do wrong? This is not right.
Wouldn't the negative 5 is odd, so we would be switching x to the 5th? Like negative x to the 5th is the same as x to the 5th?
No, this is still going to be negative x to the 5th minus a negative x to the 5th. There's something wrong, though. Fahim, what did I do wrong? I did not. Right there. This is a neither. Okay? They're not the same. They're close. A negative, anything to an odd power, the sign stays the same as what it was. So a negative times itself 5 times is still a negative, and the minus in front made it a plus. So that's why that one ends up being a neither. Okay? But that's the basic process. Okay? Let's keep going. We got little graphs to interpret. Okay. Yep. We got a graph. This one's pretty straightforward. Okay, state the value of f of negative 1, estimate the value of f of 2. Yeah, knock this out quick. you're right. My bad. All right, what do we think otherwise? Yeah, I messed that one up. My bad. The range, so the bottom value here is -2. Highest value is 1, 2, 3.
On the,
Anything else an issue? I will say, one of the things that you don't have to get hung up on is the bracket or parenthesis. That's not going to be a huge deal. Go ahead. What else? Yep. So we can't really tell whether it is included in that value. I think it's touching. If you put a parenthesis instead of a bracket, it's going to be okay. They are not going to ding you for that on the exam. Okay? All right, one more thing quickly. Now, I know we don't have a lot of time, and I would ask you to finish this one on your own. But we have two functions here that are connected, right? And they split right here. What kind of function is this over here? Absolute value. This is a constant. So when I put them together, what is that function known as? Piecewise function, your favorite, okay? And you'd have to write your conditions, then write your rule equation for the left, your rule equation for the right. You have your first homework assignment tonight. It is in Canvas. Please do it on a separate piece of, separate note, and have a great day.